Um, okay, so let's start with running IPython notebook, everybody. So now everybody has the setup, right? You guys can run the IPython notebook at the same time as me, right?
Yeah.
Okay, perfect. So let me, for example, for my case, I need to type, maybe I should increase it or... Yeah, so I need to activate my environment, and my environment's name is EE551. Can everybody see it? Back row? Even more? Good? Okay. Okay, so I'm activating my environment. Can everybody do that? Okay, here, for example, in my machine, it tells me that I'm in this environment, EE551. So whatever environment name you guys have, you can just enter that one. And in my case, I'm gonna type, oh, by the way, you should also look where you are. You know, for example, in my case, so this is the directory I'm at. So I'm going to say documents, courses, okay. And here I'm gonna CD to the lectures. Of course, you don't need to do this. I mean, whichever directory you guys want to work on, you can just CD to there. So in my case, it's lectures. And now I'm gonna start running the IPython notebook. Okay, so let me clear this a little bit. So, is there any issue? So it actually creates you this this web browser in your case. But this is only for the lecture. So for your assignments, you don't need this. But you can run the things as I'm running at the same time. So for me, I'm gonna work on this IPython notebook that I already have, but you guys can say new here. You can start a new one if you like. You can say new, and here you can click the name, the name of the notebook, however you like. Okay, so in my case, since I already prepared something, I'll walk through that. Okay, good. How is the font size?
Can you make it a little bit bigger?
Bigger?
Yeah, the terminal is good, but it's still.
Okay.
Yeah, it's good.
Good now. Okay. So can everybody start the IPython notebook now? All right. Okay. So last week we were left off with the tuples. So remember, we went through strings and numbers and lists and dictionaries. There is also another object type, the core object type that Python has, which is tuple. By the way, if you guys are wondering how I type this, it's really just you can just type this like that. So it gives you more like a, so it gives you this markdown option. So you can change it from here the way you want. So in my case, I say markdown and I type this. For example, if it is just like 1 dash, it will be bigger. If it is like double, it could be smaller, you know, or you can just make it a regular notebook. Okay, so is everybody good? Are you guys having an issue? Okay, so what is a tuple? So tuple is just an object that's like a list, but that cannot be changed. So that's the fundamental difference between a list and also a tuple. So remember last week we talked about this immutability and mutability. So tuples are immutable, okay? So they cannot be changed. So the way you create a tuple is you just add parentheses like this. For example, this is like in parentheses, I can just create a tuple of 1, 2, 3, 4, right? And if you click Shift Enter, it actually creates this tuple. So if I wanted to create a list, what kind of parentheses should I put? Exactly. So if it was like this, that would have been a list. But since we are working on tuples now, I had this regular parentheses. So most of the things that work for list also work for tuple. For example, for list, if you remember, I can just type this len of t, or len of whatever list or tuple. It actually gives you the number of items in that object. So in this case, of course, it's 4. Because it has 4 items in this tuple. And similar to the list, you can do the concatenation just by using this summation. But summation here means concatenation, but summation with numbers mean like mathematical summation, right? What was that called? What did you call it? Say it again? Right, exactly. So it's polymorphism. So this summation depends on the object type you are operating on. So now we are operating on the tuples, so it understands that it will mean concatenation. So the output of this is going to be your original tuple 1, 2, 3, 4 plus 5 and 6. So I just concatenated. Okay? And again, similar to the list, you can do the same indexing and slicing with the tuples. Why does it take too long to type, actually? Am I going too fast? No. Okay. Okay. All right, so similar to list. So here, when I say t of 0, what is it going to output? 1, right? So exactly the same as list. But can I run this operation? I told you tuples are immutable. Does it work? Who says it works? It should work. Who says it doesn't work? Okay, good. Yeah, so of course it's going to complain because tuples are not, you cannot change tuples. However, you can actually create a new tuple with the same name. So I already had this tuple, which was t. So I can just slice it. So what is t1 to all the way to the end? What does it give me? Remember, t was this 1, 2, 3, 4. So t1 to this column gives 2, 3, 4, right? So I'm adding 2 with 2, 3, 4, which is going to be 2, 2, 3, 4, right? So I just changed the assignment. So you can do this. You can assign a new tuple with the same name. It doesn't actually, so it just creates a new space for the new variable. It just forgets what t you had before and creates another variable called t. So this is doable. But you cannot just change the values itself like we try to do here. Okay.
Yes,
Yes.
Does it work without the comma? After the 2, without this comma, is it work?
Oh, that's a good question. Let's try. No, it didn't. It didn't work. Okay. All right. So, do you understand why it didn't work? From this error?
without a comma, this is just integral and not a two.
Exactly. Yes. So when you don't put the comma, very good observation by the way. Without the comma, it is just an integer, and it doesn't know what to do with integer and tuple. So this is the error that it's complaining about. All right. So let's go back. All right. So like lists and dictionaries, tuples also support mixed types and also nesting. But they don't grow and shrink because they are immutable, right? So here I'm creating another tuple, which is called T again. So each of the items has a different type here. So the first item is a string, second item is a number, third item is a list. So in this case, I can run this. So so I created this. By the way, so this is another interesting observation. So I didn't put parentheses here. So without the parentheses, by default, it gives you a tuple. Okay? So if you want it to be a list, you should add these parentheses. But if you want to force it, you can just do this, and it will still be a tuple. But you don't need anything just to create a tuple. So it works. Okay. So what's the output of this should be? T1. 3.0, right? Okay, good. So what is T21? 22, right? Nice. Okay. So does this work? T append 4. Who says it should work? Who says it doesn't work? Okay. Yeah, so you guys got it, right? So you cannot actually shrink or grow the tuples because they are immutable. But if it was a list, this operation should have been fine, right? You just say, it will just grow the list. It will just add another item to the end of your list. So in this case, of course, this is going to complain, as we expected. And here, every time when you get an error, you should always try to interpret it. Okay, here, tuple object has no attribute append. Right? Actually, it could have been nicer if it said that you cannot do these operations with tuples because they are immutable, but still it gives you some information. Okay, so this is kind of the end of the object types, the fundamental object types that we started talking last week. So let's now talk a little bit more about so this is actually chapter 7 in the book. So now let's explore this data type category, the numeric types, and also operations. So how to do some basic numeric operations that you will need to do. And also let's try to understand what happens when you create a variable, all that. So here, yes, so in the book it says, so it's really, I find it confusing to understand it just from these commands, but still you can try to understand what it really means, and then we will demonstrate as we go through. Okay, so here it says variables are created when they are first assigned values. So it's clear, right? So yeah, when you first assign a value to a variable, it's already created. So variables are replaced with their values when used in expressions. Okay, this is not very clear what it really means. So basically, when you assign a value to a variable, in the next operations it will use the value of that variable. So there's a value and also a variable. Okay, And so they must be assigned before they can be used in expressions. This is obvious, right? So if I don't have this variable called a, and then if I try to take a power of it, a square of it or something, then it's gonna complain. They need to be assigned. So variables refer to objects and are never declared ahead of time. So this is a little bit more confusing, maybe. So I think this will be more clear when we start discussing about the mapping between the variable and the object. Okay, so let's continue with some basic things first. So here, I'm just assigning a value 3 to variable A and value 4 to variable B. So names are created right away when I run this. So you don't need to declare ahead of time. And so basic operations you can do. So now A's value is 3. So every time when I type A, it's gonna take the value of A, 3 plus 1 here, and 3 minus 1 here. Okay, so what is the output of this operation, by the way? What is the type of the output? Integer? We just talked about tuples, right? So since I didn't add anything, it actually understands it's a tuple. So when I run this, it's gonna see. So you see that it actually created tuple structure. And so very basic operations, as you can guess, you can actually do the multiplication or division. Same. So in this case, it creates this. So it still creates a tuple, which is B was 4 times. Okay. Yeah, so Python has changed the division. Actually, it used to output just an integer before, but with Python 3, now it outputs float, which was very confusing thing between Python 2 and 3. So this time you know that when you do the division, it actually does it does the float operation. So for modulus and power, you can do exactly the same thing. So if you want to, for example, here the value of A was 3, and if I want to check if it is even or odd, I can just do this modulus operation, which is done by this percentage symbol. And also to take the power, you can basically just do this, basically. Okay. And you see the output for all this is still integer. Okay. All right. So what about if I have mixed type operations? So this is an integer. This is a float. So the output is going to be 2 plus 4. It's going to be a float, right? So it actually goes to a more complex type. And same for this operation. So what am I doing here, by the way? What's the output of this? 2 power 4. B was 4. 16, right? Okay. So you see now both of the items in this resulting tuple became float, because one of the operators were float, so Python understands it should go a little bit complex. All right, so this is another way to illustrate it. So if you are curious about the type of the object or a variable. Oh, by the way, no, variables don't have types. But anyway, so for the object here, if I just say type 2, you should be able to get integer. Okay, and if you write type 4, you can get float. So this is actually important because many people complain about Python that you don't use types, you never declare types. That's why it's more error prone. But as a Python developer or user, you guys should always be aware of what types you are operating on, okay? So it still uses types, but you just don't declare it, and Python just interprets it as in the most obvious way. But sometimes things can go wrong, as we just illustrated with this two as a tuple thing. Okay, so this is going to be, of course, again, float. Okay, so now I never declared C, and of course, if I try to do something with an undefined object, of course, this is gonna give me an error, right? It's obviously. Okay, so remember, B was 4, A was 3. So what's the output of this operation should be? B was 4, A was 3. 5.04. All right. Anybody else? Yes. But why is that a float? Because both A and B were integer.
Not by 2, well.
Exactly, yes. This division actually makes it a float. All right, so, okay, so here maybe I should do this. 4, 2 plus 3. Okay, so what about this one? So this will be the same as right? So 0.8, right? Yeah. So as in basic algebra, those parentheses actually have the same meaning. So without a parenthesis, this division has priority, but with parentheses, you're actually telling Python to compute this first, right? It's clear, right? Basic algebra. Okay, so let's also talk about the display formats, which, so this is something you will need to use when you either debug your program, or if you want to monitor the values of something. But you may not need very really detailed precision. You may need just like 2 decimals after the comma. So in this case, for this one, well, let's see what it prints. So when I just say print none, it's going to give me this 3333 as much as it can fit with this precision. But let's say you want to print it in a different format. So here this percentage E means scientific format. For example, if you have 0.00001, it's going to be 1E minus 3. So that's a scientific format. So in this case, it actually prints it as a scientific format, basic. So it adds this E minus 1 here. So basically that just means 10 to the minus 1. Okay? Or let's say you only want to print the floating point only up to 2 decimal points. So you just want to plot 3.33. Then you can just use this format. Okay? If you don't want to see all the decimals. So all you do is you just say percentage dot 2f, for example, in this case. So dot 2f means the 2 decimal points. Give me the 2 decimal points, and then it gives you that. So if you say 4, of course it's going to give you 0.333. But it's important to use these percentage operations for this. But there is also, so this is a little bit newer format. So people just, so instead of doing it this way, adding these percentages, people just say actually dot format. It gives you exactly the same result. You know, so I can keep changing it. Just gives as much as decimals you want. Okay. And for example, for this one, so this is pi, right? So for pi, I'm telling Python to give me these 6 decimals. So this is what it's going to plot or print. Sorry, yeah, print. As you see. Okay, so this is more for displaying and it could be useful for you guys when you do debugging or want to print the values to your shell or IPython notebook like this. Okay. Okay. So let's also talk about the comparisons. Is there any issue? Okay. Yeah, so this is very similar to basic algebra again. So the normal comparisons compare the relative magnitudes and return a Boolean result, of course. So it returns, so what's a Boolean result? It's either true or false, right? And we would normally test and take action based on the result of these statements. So for example, so output of this, 1 less than 2, it's going to be, of course, true, right? So this is the output. Or, by the way, you can also do the mixed type again, like you do in most of the other mathematical operations. So you can just say 2.0 greater than 1. In that case, it gives you true again. And of course, this is going to be what? 2.0 equals 2.0. Yes. And what about this? So this means not equal. 2.0 is not equal to 2. Is this true or false? Okay, let's see. Yeah, obviously. Right, because what does this mean? They are actually equal to each other, right? So this is something, you know, so for some really basic things it can get a little bit confusing. But what if maybe I should mention it later. 2.0 is 2. Okay, so this is, and so what does that mean? 2.0 equals 2. This is true. This is false. Do you see the confusion here? Did you get confused? Yes, right? This is pretty confusing. So when you say, so when you do this, when you just look for equality, that looks at the value. Are the values, do the values match or not? 2.0 and 2, in terms of values, they match. But 2.0 is not 2. Because when you say this, it actually looks for everything all together. So it also checks the type, you know, so extra things that the object has. So we'll have more examples about this, but just be aware that in Python, is different than equal to. Okay? All right, so now we can define this x, y, z, 2, 4, 6. So you can basically just run these range tests or comparisons in a changed format. Okay. So x less than y less than z. Of course, it is true, right? So you can do this. Or you can do this separately. X is less than y is less than z. You know, so it looks at this condition and all together. So this is another way to write it. Or you can say y is greater than x and y is also greater than z. What is the output of this? It was 2, 4, what was it? I forgot. 2, 4, 6. So 2, 4, 6. Right. And this one is going to be false again, right? So this is the same expression as this one, just writing. So this one is written in a changed way, or this one was written separately. So it's going to be false too. Okay, so what about this? 1.1 plus 2.2 equals to 3.3. Who says this is true? Okay, don't be too skeptical. No. Who says it's not? You say it's not. Why? Because I'm asking, right? Otherwise it will be too obvious. Right, okay, so let's do this. So it is false. Because you need to be careful with the floating point operation. So floating point numbers may not always work as you expect and may require conversions or other massaging to be compared meaningfully. So, okay, what if, can I do this? 1.1 plus 2.2. See? So there is this, you might have these extra floating point values here. So this is not exactly equal to 3.3. Okay. So if you really want to compare it, you can say integer. For example, when you say integer 1.1 plus 2.2 is equal to integer 3.3, of course this is going to work, but you can also use those formatting that we mentioned. You know, so you can say, so whatever the precision you want, and then you can make them equal. But just be careful when you check equality for the float numbers, okay? So this is, of course, going to be true. Okay, so how is everybody doing? Good? Okay. Yeah, I hope I confused you enough with these equalities and is and all that. So I'm actually trying to remind you that operations that look really, really simple might actually be the reason for the bugs. You know, so if you don't know these fundamentals with this programming language, it might take you hours or maybe days to figure out a bug in your code, right? All right, so let's move to bitwise operations a little bit. Don't worry, we'll come back to this is and equality again. I'll keep reminding you those things. So for the bitwise operations, so this is actually something you might be asked in software engineering interviews too. So there are so many questions with bitwise operations, do this, do that. So let's, so first of all, what does that mean? So basically Python supports operators that treat integers as strings of binary bits. You know, so you can represent any integer in terms of binary, right? Binary bits. So Python actually understands those binary bits, which can become handy if your Python code needs to deal with some binary data, whatever. Okay, so let's create this variable x, which is equal to 1. The value is 1. So this operator, that means shift bits to left by 2. So what does that mean? Oops. So I can represent x as this, right? 0, 0, 0, 1. So I'm actually telling, let's do this markdown. I'm actually telling my Python program to shift everything to left. So this 1 is going to shift all the way to here. So it's going to become 0, 1, 0, 0. So if you have, you are just assigning zeros, of course, if you don't have more digits here. So are you guys clear with this? So when I just shift bits, shift the values by 2 bits, it will become this. So if, let's say, if it was this, what would that be? So I'm going to, so this is going to move here, right? And this is going to move, oh, this is, so this is going to move 1, 2. So I moved these digits, binary digits, by 2 to the left. It's clear, right? And if you don't have more digits to add, you just append zeros, basically. Okay, so in this case, again, back to what we had. Let's say I had this 0, 0, 0, 1, and I moved the digits to left by 2 bits. So what is the value of this going to be? 4, right? Yes. So it understands when you type this operation, it understands you are it's dealing with bits, and you are telling whatever value it was represented in terms of binary. I just need to shift the bits by 2. Okay, so what is the output of this, you think? So this is OR operation. So you can actually do OR operation by this. Okay, so let's see what that means. So we had 0, 0, 1. Again, let's do this markdown. And how do you represent 2? Right. By the way, I'm just representing everything in terms of 4 digits, but you can add zeros as much as you want here, right? Doesn't change the result. Okay, so if I do OR operation with this, what is it gonna be? 0, 0, 1, 1, right? And what is that equal to? 3, right? Okay. And what if you do AND operation here? What's the output of this going to be? Yeah, this one was too simple, but yeah. Let's do something more interesting. So basically 3 and 5. Okay, does it work? Let's go. Oh, okay. So this one didn't work because, okay, what should that be? So what is this? 0, 1, 1, right? And the other one is 1, 0, 1, right? So if you do AND operation with this, yeah, okay, it works, sorry, yes. So so this is going to be 0, 0, 1, right? Which is 1. Okay. All right. So what if you want to see how an integer looks like in terms of binary format, right? So let's say I say binary of 4, which I expect something. Okay, I didn't write it here, but something like 100, right? So Python has this built-in function that you can use if you want to look at the representation of a number in terms of binary. So it actually tells you this. So this is what is this output, by the way? What's the format? What's the type of this? What does it look like? Okay, it's easy. I can check. I can say what is. Oh, sorry. It's a string. So it outputs string. But here it looks a little different, right? So it is not just 100. It also has this information in front that actually just to indicate that the number is being displayed in binary. That's it. So that's more like additional information. But you can actually just represent the same number as this. Instead of just typing x equals 1, you can type this way, 0b0001. It understands that it's actually 1. So let's run this. And then if I type x, so it knows that it's 1. And you can shift left still, which is going to be, again, if you remember, it's going to be 100, which is 4, right? And you can do exactly the same thing for the shift. So after I shift, what does the number look like in terms of binary? You can actually see, okay, this is 100 again. And you can do the same thing. So here you can do bitwise OR with the binary representation like this. Yeah, it's 3, and you can do the same thing with AND in order to get the AND operation. So it's, of course, it's gonna give you this string as an output. Okay. So this is how you represent numbers in terms of binary and how you do operations on them. So Python again has another nice method which is called bit length. So this is again a built-in function. By the way, remember the word so I'll be saying built-in. So you should, when I say built-in, you should understand that you almost don't need to do anything to be able to use that method. That means Python already knows it. You don't need to import any package or anything. So it's a built-in method. So in this case, I have this x, and then I can actually look at the bit length, which is the number of bits required to represent a number's value in binary. Okay, so how do you represent 8 in binary? Yes, 1000, right? So let's type it here. Okay, so this binary is going to be what?
0b.
Yes, 0b1000. So for this x dot bit length, what do you expect that to be? I mean, you don't know. Okay, so let's say we don't know what this method does, but it's kind of obvious from its name, but still it's good to be skeptical. So I can just say x bit length question mark. It's okay, number of bits necessary to represent self in binary. So basically, for example, for 37, it says you need 6 bits, sorry. Okay, Now I'm like, okay, now I know what it is doing. So for this, x dot bit length should be what? 4. What about this? 4? Not 2? 2 or 4? 4, right? Right, because of that extra 0b as a prefix to your binary representation, it adds 2 more items to your string, and we are just subtracting 2 in order to get the true length of this number. So basically, the output is what we expected, what we just discussed. All right. Okay. So other built-in numeric tools. Okay, so in addition to core object types, so Python also has built-in function and standard library modules for numeric processing. So these are the library modules that you can also do some numeric processing, like really basic things. But for this, you need to import it if you want to use the method of these modules. So in this case, we just say import math. So now I have access to all the methods that this module math has. Maybe I can actually type math. Okay, see? So you can just say, okay, what do I have? What am I getting with math? I'm like, oh, okay, makes sense. Cosine, sine, all these functions that you will need for your calculus course, almost, pretty much. They are all available in this math module. Looks like a useful module, right? So you can get the most basic constants with this. So you can get pi or exponential value. So here, see, it actually gives all this precision, all these decimals, and you can do some really basic operations, you know. So you can just take this sine of 2 times pi divided by this, you know. You can just get the value here, and you can also take the square root of this. So all you need to say is to call that module dot the method in that module, which is square root, and then give the input to that. Okay. So for exponentiation or taking power, so there are actually 2 different ways to do this. You can either take this power operator, but so for power you actually don't need to import math. So this power method already exists in Python, so which is nice. It's already there. Or you can do Python power just by this double star too. And here this is just for the float representation. So basically, so there are several ways to do the same thing, pretty much. So these absolute value or summation, for these you also don't need to import math module again. So they already exist in Python ecosystem. So you can just say absolute value of whatever number you have, or you can just say sum. That makes sense, right? That it's very clear what the sum should do in this case, right? I mean, if you get skeptical again, you can just say you know, so here it says iterable, so it is like something, we'll talk about iterables, but it can be something like a list or tuple or anything, and then it just sums all the items up. But don't do this, okay? Sum equals sum, you know, so this will work, but it will mess up your sum method. Oh no, sorry, it takes two. Okay, so you guys see the problem here? Now I cannot use sum anymore because I just assigned a variable to sum. So sum is not a method anymore. Sum is a value. But actually Python kind of warned me here. You know, when I typed this sum, it was saying, hey, look, you know, so it kind of color coded it. That it was kind of obvious that I was doing something not very smart. So now that method is just a variable which is 10. So if I try to call sum again, like what I was doing, it complains because it's an integer object. It's not, you cannot call it. Okay, so be careful with the name assignments you guys are doing. All right, so same with the minimum and maximum. You know, you just give all these values, and then it gives you the minimum and maximum. But be careful with the usage. For example, in order to use sum, I cannot use sum anymore. I lost it. But in order to use sum, so this was the this was how you use it. So you actually give this iterable or tuple or list inside it. But here you don't need to do it. You can just give as many numbers as you want, right? So for that, it's always a good idea to see by doing either this question mark or doing this dir to get how you can use it. So in this case, it's gonna give me min and max. And what's the output of this again? This cell? Yeah, but what's the type? Type is tuple, right? Yeah. Okay. Okay, so minimum, maximum, summation, they were more basic methods you may need. But things can get a little bit more complicated. So for those, you can actually call the math module. So for this, if you want to take the floor of these values, so what is the output of this, by the way? 2, and this -3, right? Okay, so this math module actually gives you that. You can also truncate. I actually didn't know that you could do this before. So basically, just to get rid of all these decimals here, you can just, you know, just truncate all the rest of the information and just keeps these 2's or -2's. And of course, we have been doing these type conversions a lot. So you can do integer for both of these floats. It's gonna give what? 2 and -2. And also, you know, so for round, it's simple. Okay, so round actually takes one more parameter here. See, so in these cases, I only gave the value that I wanted Python to take the round, but there is also the second parameter to this function. What do you think it could be? Any ideas? Okay, then I can again take a look. Number of digits. So it actually here you define the precision in decimal digits. So basically, this is going to give you number of decimal digits you want. So that's it. Okay. So you understand it, right? So some things are really very common sense that, of course, you are running, but there might be some extra parameters you may want to check in Python. Okay, so this is interesting. So there are actually, there can be multiple ways to do things in Python. So for example, if you want to compute a square root, you can either use a module function from this math module. So remember, it has math.square root. Or you can use an expression, or you can use a built-in function. 3 ways, okay? But always try to, so don't pick these just randomly, okay? So be smart at what you are doing. For example, okay, so I know that I can take square root by using this math.square root, okay? So for this, okay, fine, that works. For expression, so can you guys tell me how to do it with expression? When I say expression, I mean double star. How can you do with double star for this? This? Huh? Exactly, yeah. So you can do this, right? So you guys know know this expression. So this is another way. And this power operator, the built-in function that Python has, unless you assign some variable to this power before, then so that's the third way. So we have 3 different ways to compute just square root. Okay, but again, so the modules such as math should be imported, and built-in functions such as absolute value or round are always available without any imports. So modules are external components. So math module, in this case, is an external component. And built-in functions are always live in your namespace. So Python automatically searches for those built-in functions, which was like in power in this case, for example. Okay, so let's do something a little bit more fun or interesting. So let's say for you, timing is important, okay? So you want to pick the way to compute square root in the fastest way. So it's really important. Otherwise, your boss will complain. So in that case, you can actually import this time module. So I just say import time, and then I'm gonna look at the elapsed time of this. So each way of computing the square root. So for that, what am I supposed to do? So first, you define the start time, right? So you are telling your machine, your computer, that this is the time I'm starting. And then you do some operations, and then you have the end time. So you mark the end time too. And of course, the elapsed time is going to be the difference between those. And here, what am I doing here, by the way? So it's a list comprehension.
You make a list that all of the elements is 12.
Right. And in other words, I'm actually, yes, I'm creating a list, but the reason I'm doing this is because I want to run this 10,000 times. Because I want to do it 10,000 times, because maybe if I run it only once, it might be just luck. Maybe your machine was a little bit hot at that second, but then when you run the other one, maybe it was different. But when you run it 10,000 times, you actually you collect more data points. So I'm trying to make sure that I can measure the difference of the performance of each of these methods better. Okay, so is everybody clear with this? Do you guys understand what I'm trying to do here? So I'm measuring the elapsed time of computing square root of 144, which is computed 10,000 times. Okay, so let's do this. Okay, well, I didn't need this much precision. I could have actually used the format method, but anyway, so it took 0.0015, whatever. All right, so this was to compute math.square root. What about the expression? I'm doing exactly the same thing, except that instead of using math.square root, I'm using this expression by using this double star. So for this, if I run it 10,000 times, let's see what it gives me. 0.0003. This one was 0.001. This is faster, right? Yes. Okay, so what about power? So I'm doing exactly the same thing. I'm marking the start time, marking the end time, looking at the elapsed time, both of these, and compute the square root by using this power built-in function that Python already has. So for this is 0.001. Okay, 0.001, 0.0003, and 0.001. So obviously, this is the winner, right? Interestingly, in this case, so this is just one simple exercise to decide what way to use, or if you have several ways to do something, one of them is probably better than the others, and for that the best way is actually to be more skeptical and to do more analysis about your runtime, all that. Okay, is this clear, everyone? So obviously, you can just use this expression instead of importing math module if you want to compute square root, basically. And you understand why it can make a difference, right? If you have a really huge program processing really huge data sets, even a second is really important for your design. Okay, so standard library random module. Okay, so there is also another module which is a standard library. When I say standard library, by the way, that means you don't need to do pip install random. So it already exists there. But for example, for NumPy, it doesn't come with Python unless you install Python with Anaconda or something else. But if you have this core Python that you guys installed, it doesn't come with that. So for NumPy, for some modules like NumPy, scikit-learn, or SciPy, all that, you need to install. You need to say pip install whatever. But for these modules like random or math or whatever, they actually just come with Python itself, so you don't need to install. And the best way to check if those things work or not is actually you can just say, for example, I think I don't have this package. See, so it says no module named joblib. So for this, I need to go and say pip install joblib, and then my machine will get it. But for random or for math, you don't need to do that. So it just comes with your Python installation, but you still need to import. So, okay, I imported and it didn't complain. Yes?
So even though it comes with the Python installation, we still have to import it, but why is that the case? Why can't, if you're already installing Python, you're already using Python, you're already installing all these other packages, why doesn't it just come together? Why do you have to import it?
Yeah, very good question. So the question is, in case for the videos, why doesn't all these packages come together? Why do we need to install them separately? So everybody has different needs. You know, if you are working with I don't know, machine learning, you need some really different deep learning libraries, machine learning libraries, all that. But if you're a system engineer whose work is actually just to manage the processes, all that, you don't need those libraries. But so, of course, this is a good question. And for example, that's why people use Anaconda, because Anaconda is like a to-go way to install Python if you are interested in data science or machine learning, all that. But not everybody is a data scientist, right? So in this course, that's why I didn't ask you guys to install Anaconda. I wanted you to have a full control of your environment so you can install as many packages as you want, and you can also uninstall packages as you want. Okay, but there is also that's also another reason why I really emphasize this virtual environment a lot, because when you keep installing things to your original Python, you don't want to mess up with your system. So you create a separate environment. That's the reason. Okay, so I import random, and then I can just create a random value by just calling this random.random. So obviously, but again, I'm not really clear what it is giving me. I mean, is there a range for this? Is it supposed to give me an integer, whatever? Oh, okay. So so when I type random, it always gives me some random value between 0 and 1. That's why this value was between 0 and 1. So if I run it again, do you think it's going to give me the same thing or different thing? Who says same thing? Different thing? Right. Okay, so it gives me different thing. What if I want my my random module to give me the same value every time when I call it for the first time? So just give me the same sequence of random numbers. So in that case, you can actually assign a seed to your random. So I say random.seed 100. So I create one random. Okay. And then so if I run this one more time, well, is that gonna be the same number as this one, or is that gonna create a different number, you think? Who says same? Who says different? Okay, good. So it's gonna give me different number again. All right, so now I reset the seed of my random. So it was 100 before, I reset it 100 again. So what do you think the number will be this time? So there is a reason I'm assigning a seed, because I want to get the same sequence. So if I run my experiment next time that uses random numbers, I want to get the same result every time. Okay, so who says this is going to be something different? Who says it's going to equal to this one? It does, right? Yes. So I reset this random generator, and then it gave me these two sequences, 0.14, 0.45. And then I reset it again. And then when I create, so it gives me the first number that we generated here, and the second number is going to be 0.45, which was the same as this one. So it gives me, of course, every time when I call random, it gives me different number, but the sequence will be the same as what you generated before if you use the same seed. Does it make sense? No? Yes? Okay. Yeah. Yes? So that 100, it was just to assign some seed number. It can be anything. You know, so if I assign something else, so here I had 100, right? So now let's say you wanna put your zip code. Yeah. Okay. 0853. Okay. Forget about this. Sorry. Okay, so in this case, now the first number that it generated is different than what I had before. So here, every time when I assign a seed to some number, when I say 100, the number 100, seed number 100, always generates this one first, always generates this one second. But when I give this 853, it always generates this number first, and then this number second. So if you want to get the same kind of sequence of random numbers, you need to assign the same number. So you can assign anything. Does that answer your question?
So the number stands for maybe the position of their storage.
Storage?
Yeah.
I know
Yeah.
what it means. It
Okay.
means that this number already has been stored in the Python. So every time we open Python and we input the seed 100, we will get the identical number.
Yeah, so it actually it uses some algorithm every time to come up with a number.
So every time, no matter whose computer, no matter when I open the Python, we input the seed 100, we will get the same number.
Oh, yes. So in everyone's machine, it will be the same.
Why?
So it's actually a good thing because you still want to generate sequence of random numbers, but you want to get the same result in everyone's machine. You know, so let's say you run some experiments using some random numbers, and then you say, oh, this is my result, and I want to generate exactly the same result as yours. So if I use your seed, I'll generate the same result.
Okay.
You know.
Thank you.
One more question. Okay, and so that was about the seeds. You can also, so this random module also has different methods. Like when you say rand int, it actually generates an integer, as you can tell, between 1 and 10. So it's this. Oh, interesting. So let me run it one more time. You know, so every time you run it, generates something different. Okay, and always between 1 and 10. Yeah, there are other things you can do with this module. So you can actually choose an item at random from a sequence, or shuffle a list of items randomly. For example, in this case, so let's say we have this list where each of them is some other string, and then when you say random.choice, it actually gives you meaning of life. Okay, no, I didn't plan for it. And so you can run it one more time. See, this time it gave something different. So, you know, you can just, if you randomly want to choose an item from your list, I wonder it actually works with tuple too. So let's make this tuple. Oh no, it's me. It's not the tuple. By the way, if it is too long, you can do this. Oh, I forgot to close. Okay. Yeah. Yeah. So you can, for tuples, it works too. Or you can also shuffle things as well. So in this case, let's say you have these hearts, clubs, diamonds, spades, And then when you say random shuffle suits, it's going to give you, oh, does it do in place? It does, actually. So you see what happened here? Guys? So I had this list with these values, and when I ran a random.shuffle suits, it didn't output anything. So if your method doesn't output anything, you should probably be suspicious about the in-place operation. So when I ran this random.shuffle suits, it actually did the shuffling in place, and it changed my suits, the list. Okay, but what if this was a tuple, which is immutable? Do you think it will work? So this is something that does things in place. Who says it should work? Who says it doesn't? Okay, good. Yes. So, and the error is, it says tuple object doesn't support item assignment because it's immutable. All right, so let's just for the records, let's go back to this. See, when I ran it second time, it actually changed the order. So every time when you call this method, it gives you a different result. Okay. All right. So that was about different useful Python modules like random or math, all that. And also some built-in functions. So now let's move to a different object type, which is called sets. So this is really what you see in the math class. Again, math course. It's so the same logic as sets. You know, you can define a set. You can take the union, intersection. But there is one fundamental thing about sets, right? Can you have two same items in the set, in math, in calculus, in a set? No, right? So each set should have just one item only once. You cannot have the same item twice. So that's one thing. So in terms of programming language, so you can describe set as an unordered collection of unique and immutable objects. So this is important. So they are, so first of all, it's unordered. Maybe actually I should do this. Unordered is important. Unique is important. And immutable is important. So yes, so it's an unordered collection of unique and immutable objects that supports operations corresponding to mathematical set theory. So by definition, the item appears only once, no matter how many times you add it. You know, when you define it, you can keep adding, but it doesn't matter. It will result that item only once. And sets have a variety of applications that we will talk about, especially in numeric and database focused work. So they are actually almost like, so do you feel they might be similar to dictionary, kind of? Why? Because dictionaries are also unordered, right? Unlike list and tuples. But they don't have the values, unlike dictionaries. So in dictionary, you have both key and the value, right? So it's they are mapping from keys to values. But for set, you only have the keys. And so similarly, in a dictionary, can you define one key twice? And does it make sense? It doesn't, right? So same as set. So since it only consists of keys, you can have it. So they have to be unique, basically. Okay. So how do we create a set? You can just do the built-in call again. So Python knows what you mean by set when you say set. So when I run this, okay, so what do you think the output should be?
1, 2, 3, 4.
Right, yes. I mean, it doesn't complain that I'm entering 4 twice, but when it creates the set, it actually only creates this 1, 2, 3, 4. And you see that the result is actually a curly bracket. By that, you can understand it's either a dictionary or a set when you see the curly bracket. But in this case, since it doesn't have the values, it's just a set. Okay, so another way to define, you can again say set of this, and it creates, see, so the order is different. So it just orders however it likes. And when you use set, you should always keep that in mind, that they are unordered. Okay? So although I defined the set in this order, it just created this set like this. And you don't necessarily need to use this built-in function set. You can also create a set by just using this curly bracket. Okay? So but it again, so the order is again different than what you defined. Okay? All right, and so remember, if this was a dictionary, all you need to do was to assign values to this, right? So let's say all that. So if it was a dictionary, but since this is a set, there are no values. It's just the keys. Okay, so do you think this will work as .add a lot? Before you run, of course. Who says it should work? Okay, who says it shouldn't? Okay, yes, it should work, right? I mean, why not? And now when I look at S, see, so it added this new item to my set, right? So you can also do some basic set theory operations as we taught. So let's create this set again, 1, 2, 3, 4. Okay, and you can take the intersection by this AND operator, which is interesting because we just used AND operator for bit operations, right? It meant like taking the AND operation for like bitwise operation, and now it became a set operation. Again, it's Python, so AND can mean different things for different objects. So in this case, what is the output going to be for this?
1, 3.
Right, 1, 3. So it is the intersection. And for this, so this OR operator we saw in bitwise operations, it actually means union in this case. So when you take the union with S1, which was 1, 2, 3, 4, the output is going to be 1, 2, 3, 4, 5, 6, right? So it's the union. Okay, no surprise there. So okay, what do you think the difference means for set? So what do you expect the output to be in this case?
2.
Right. should be 2, right? So S1 was 1, 2, 3, 4, and you are taking the difference with 1, 3, 4. So the only difference is 2. So this subtraction operator just became different for sets. All right? Greater than. What do you think it should mean? Hmm? You think size? Or superset? Is it a superset of 1, 3? Or if you say less than, it will be a subset. So for this, what do you think the output should be?
True.
Right, so it should be a Boolean, first of all, right? It's a yes or no thing, and it's going to be true. Okay, so sets are mutable. In other words, they are changeable. You can keep adding items to sets. But you can only add immutable object types, which is important. So you cannot add, okay, maybe I should also, can only contain immutable object types. So in this case, you cannot you cannot use lists or dictionaries as an item in sets. But tuples work. Interesting. So when you create a set, the item cannot be a list or dictionary or anything which is mutable, but tuples, strings, numbers, they all work to create a set. Okay, so let's demonstrate this. So I can actually create an empty set by just running this set as this, and I can just say add. So in this case, okay, it created a set for me with an item 1.23, and now I try to add this list to my set. Do you think it's gonna work? No, based on what we just said, right? So I warned you that you cannot add mutable objects to set. So in this case, it complains. Or if you try to add a list, dictionary, in this case, it's gonna complain again. What about I try to add a tuple? Is it going to work? It does, yes. Yeah. So no list or dictionary, but tuples are okay in this. So you see that the list has both 1, 2, 3 as an item and 1.23 as an item too. And in this case, I mean, for ordering, it's hard to tell anything, right? So when you create a when you create a tuple out of strings, it kind of has this alphabetical order. You know, you can still maybe guess. But for this one, it's really not clear. So one item is a tuple, one item is a float. So ordering is really almost, you can think it as almost like random. Okay, and we can take the union. So we created this set 1, 2, 3 and 1.23, and we can actually take the union of this with this set. And in that case, see, I have this bigger set. I just taking union. Yeah.
I have a question. Does the tuple must have the immutable elements?
So the values of tuple, you mean?
Yeah.
Okay, so let's illustrate that. Let's see. So S add, so some tuple, but of lists.
Yeah, that's what I mean.
And this one, let's say AB. No, still doesn't work. Doesn't work. Oh, what about this? This works, but when you try to add, so it has to be basically, yeah, that's a very good question, by the way. Yeah, I didn't know the answer, so I had to run it, basically. Yeah, so it has to be immutable all the way, apparently. This one doesn't work. Okay, so even the entries have to be immutable. Okay, so you can also check the membership in a set. So again, let's remember what our set was. So our set was this 1, 2, 3, and 1.23. So you can basically just ask if 1, 2, 3 is in the set, which is true, of course. And you can also do something else. Of course, it's going to be false, right? Because the set doesn't have this item, 1, 4, 3. And so as you do comprehensions in almost anything, any iterable type, you can actually do that for list 2, for sets 2. So in this case, what do you think the output will be? 1, 4, 9, okay. So what about this? Doesn't change, right? Right. So, and in order to make sure that it's a set, all I did is just adding this curly bracket, so it understands the output of this comprehension is going to be a set. So, yeah. I mean, it looks like ordered now, but don't never think sets or dictionaries is ordered. You know, so if you need a ordered type, either use tuple or list. Okay, don't use set or dictionary. So this one, yeah. So you can either create sets by doing this, by running this built-in function set. Or you can just run, I mean, this is probably not the cheapest way, at least in terms of typing, but you can create a set by just doing this too. So it's a set comprehension. So this X actually goes through each of those items, and then it creates the set, exactly the same set that you can create by running this. Okay? So everybody is clear with comprehensions, right? You guys feel comfortable with comprehensions? Okay, so for this one, okay, so let me ask you the length of this, or the number of items that this list has. How many items? 5, right? Because you have this A twice, and this one M twice too. So the output is going to be A, H, 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 M, 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 all that. Okay? And do you remember what this was, this operation? Or for binary. So for sets, union, yes, exactly. So when I create a union, it's obviously going to, oh, okay, so my S was this, 1, 2, 3, 1.23, and then it just adds 2 more items to take the union. And was what? Intersection, right. So now the output is of course going to be empty, right? Because S didn't have these 2 items. Okay, so why do we need this? Why are sets useful? So yeah, they have several common use cases. Yes, it's more practical than mathematical, you know, so you don't usually do set theory per se when you use this set type. So one example could be to filter out the duplicates in your collection. So basically, yeah. So for example, let's say you have this list which has some duplicates, right? 1, 2, 1, 3, 2, 4, 5. So you have 1 twice, and 2 appear twice too. And you want to get rid of these duplicates. You want to have only 1, 1, and 1, 2, right? So you can actually convert this list into a set that actually gives you all unique values. So this way, you got rid of the duplicates, and then if you still need a list at the end, you just call list again. So you say list of set of this list, basically. So you do this. But it's important, the order might change when you do this. So you do this if you don't care about the order. So for example, here, so in this case, I mean, it's really hard to tell what the output of this list is going to be. So this is the original list, and then you run set in order to get rid of the duplicates, and then you run list again. So in this case, who knows what the output is going to be. So the order is completely different than what you started with. Okay? So again, so you can get rid of the duplicates, but be careful with the order. Do you need the order or not? Okay, so they can also be used to isolate differences in list strings and other iterable objects. So basically, just convert those objects to sets and take the difference. So for example, let's say you want to know the differences between these 2 lists, 1, 3, 5, 7, and 1, 2, 4, 5, 6. In this case, you cannot do this operation simply by lists. I mean, you can find a way, but it's not as obvious. So with sets, you can just convert everything to sets, and then it actually gives you the items. For example, in this case, those items are 3 and 7, which don't exist in this list, in the second list. You know, so it actually just takes the difference between the lists, basically. Or you can also find the string differences in this case. So for example, here, well, hard to tell this time, but basically C, E, F are the only ones that exist in the first string, but not the second string. You know. Actually, I want to try something. I want to try this. You know, just doing something doesn't look as obvious. Didn't work. You know, so basically it has to be like this. You know. Okay, what else? so another use case for sets, you can perform an order neutral equality test by converting to a set before the test you want to perform, because the order doesn't matter. Okay, yeah. So for example, this is a really good example. You may want to use this to compare outputs of programs that should work the same way, but the order might be different. But as long as the outputs are the same, you are fine, and you want to check that. And one way to do it, of course, you can just sort everything. You can sort two lists and then do the comparison. It will work. But if you guys have taken this algorithms class, you should know that sorting is actually an expensive thing. So you probably don't want to do sorting. So basically, you can just compare these lists by just converting them to a set. So for example, in this case, by the way, so this is another way in Python to define variables. So here, when I say L1, comma L2 equals this list, comma this list, it actually assigns the first list to the first variable and second list to the second variable. You know, so one tiny thing. So what do you think about this? Is L1 equal to L2? What should the output be? Is it too easy? Is it why you are not? Okay, so it should be false, right?
Yeah.
Because they are different, and for lists, order matters. And in this case, if the orders are different, then you should say false. However, when you do set, it actually says true. You can do this too. So what do you think this is going to be? True, right?
Yeah.
Okay, so do you want to see which one is faster? Do you want to test that? Okay, let's test that. I think I already have start time dot time, okay, and okay, so set L1 for I in range okay, let's do this many times so we have a better estimate. I wonder if this will work. Let me first try this works. Okay, it works. Oh, I didn't need that output. Anyway, and let's assign this to some value so it doesn't print. And then end time is equal to time dot time. Okay, and the elapsed time is going to be what? End time minus start time. And I'm going to say elapsed time for set L1 equals set L2 is elapsed time. By the way, I'll do format. Oh, I forgot how did we do the formatting? Yeah, it was at the beginning of the lecture. I forgot already. Oh, okay. This. See, you can just copy it. Okay, so I can just type this. Okay, right? So let's see. All right, so let's do the same thing. Sort. Oh, sorry, sorted, right? Sorted. Oh, this is sorted. Okay. Okay, so it didn't make much sense. This is 10,000. Let me run it again. This is strange. Sorted is faster actually.
If your data is not too large,
Yeah, I think so. Yes. So what if I do this? No, I want to define. L1 is 3 times 1. L2 is, so I'm just trying to create something bigger. Okay, it's still anyway, so there is probably some point that you can actually break this. So probably the sorting functions are really okay. I hope I don't crash my laptop at this point. It is still running. Oh, okay. This one was 19 seconds. It's still running. Okay, I don't know. So probably this sorting function is really optimized in Python. So that's probably why it seems to be faster. But anyway, so okay, so what else? So sets are also convenient when you deal with large data sets. So let's say you have these data sets of engineers where you have Bob, Sue, and Vic, and managers, Tom and Sue. You can actually, so if you are working with really large databases or data sets, you can simply say, oh, is Bob an engineer? So, oh, because I didn't define this. Yeah, so Bob is an engineer. So you can also check, okay, who is both engineer and manager by just taking the and. So it gives you the intersection. Or you can, if you need the name of everyone in these data sets, all engineers and managers, so here you take the union, it gives you this, the name of everyone. Or you can also say, okay, who are the engineers who are not managers, by just taking this difference, this, and managers who are not engineers is easy, right? You can just say managers who are not engineers. So Tom is the only manager who is not an engineer. So this is a superset. Are all engineers managers? So here you look at the manager, you look at engineers, do they all cover all managers? And in this case, of course it's false. Or are both Bob and Sue engineers? So this is subset, right? Less than, and it works this way. True. So who is in one but not both? So you take Oh right. So it what's its name in set theory? I forgot. So you look at outside of intersection. Yeah. Complement of both actually, right? Okay, I'm sure there is a better name for this. I forgot. But anyway, so this actually gives you everyone but the intersection. And this one gives what? If this is everyone but the intersection, what do you think this should be? So the first one is union. So you take the entire union of, so both sets. And then this one is the complement of both sets. And you look at the difference between those. Intersection, right. So so C is the only one. Okay, so let's go through the booleans too. So we touched briefly about the booleans, when we were checking the conditions or is an item in the set kind of thing. So they all return these booleans. So Python has an explicit boolean data type which is called bool. I should also highlight it. So with the values true and false, of course, as its built-in name. So internally, the names true and false are also, so they are instances of bool, but they are also subclass of the built-in integer type. So they are actually, when something is a boolean, yes, its type is boolean, but it's a subclass of the built-in integer type int. So that's why true and false behave exactly like the integers 1 and 0. So true is usually, you can think true as 1, false as 0. Except they have some customized printing logic, which I'll touch briefly. Yeah, so when you print them, actually you see as a print name is true or false. Okay, so let's say, so type true is going to be what? Bool, right? Yes. So there's also this built-in method is instance. So you can basically just check the type of any object. So for this, is instance true a boolean? Is this true? It is, right? What about this? Is true an integer? Who says false? Who says true? Why do you think it's true?
Because sometimes you treat it as integer.
So basically, yeah, close. So basically, it's a subclass of integer type. So yes, it's a boolean by definition, but boolean is a subset of integer. That's why when you run this, it's going to give you true. Again, okay. Okay, so again, so at the beginning of the lecture, we started looking at this equality and is. So let's see. Do you think true equals to 1? Is this true? Okay. True is 1. False? Who says true? Nobody? You changed your mind. Okay, that's okay. Yeah, so this should be false, right? Why? Yeah, so they are different objects. Although it's a subset of subclass of integer, but true and one are different object types in a computer's memory. What about true or false? Yes. So this is just a binary operation. Okay, I mean, I can either get into this, but I want to, before starting something else, I actually want to make sure that you guys are comfortable with the assignment. Okay, no, I heard that sigh. Okay, so let's stop here in terms of the lecture. So let's go through the assignment, how you guys can submit it. Okay? Should I demonstrate, like I'm a student, how I'll do it? Will that be useful for you? Okay. All right, let's stop here. Okay, so first of all, you guys all had the link to your private repository, right?
Yeah.
So for example, in my case, let's say I'm a student. No, I think it should be something like this for all of you.
Yeah.
You know, so since my GitHub's name is this, GitHub actually created this repository for me. Yeah, you should have exactly the same thing, just with your own